Hello there. For section 3.2 for our online notes, we're going to look at solving quadratic equations. So we looked at the formula for a quadratic equation already, but now it's just going to have an addition to the end of it equals 0 on there, and that makes it an equation that we're going to solve. A quadratic equation. Okay, so we're going to be solving for x in these things. So remember, these things are called quadratics, and that just means that they are the shape of a parabola. That means that they have that power of 2 on the exponent, and we are going to take them and solve for x. Okay, there's many different ways to do that. We're not going to get into all of those ways. Factoring using the x-intercept method, intersection, we'll do these. We're not going to do square root or completing the square, and probably not the quadratic formula. You may remember some of that from high school. Factoring, obviously, quadratic formula, maybe completing the square. I mainly want to show you in your graphing calculator. So when the problem says to find the x-intercept, when the problem says to find the solution, when the problem says to find the zero of a problem, that all means the same thing. It means to solve that problem for x. Okay, and in our graphing calculator, that means where it crosses the x-axis. So we're going to use what's called the graphical method, our graphing calculator, to solve these quadratic equations. So down here, the x-intercepts satisfy the answer. This is how you solve it when it's equal to 0. That's the key on these. It has to have an equal 0 on there. And so that's where you have the x-intercepts here on this one, A and B. This parabola crosses the x-axis twice, so it has two answers. This parabola actually sits on the x-axis, so it only has just one answer. And then like a parabola like this, it's possible that it does not even cross the x-axis, so that means there's no answer for that particular problem. There's no solution to that, and that may happen. So to start off with, let me see if this is lined up. Here are our steps. Make sure the quadratic equation is written with 0 on one side. You're going to type that equation into y1. Then you need to get a good graph. Remember, we do zoom 6, zoom 3, zoom 0. That's the fit. You may have to just do an adjustment. Adjust the window. Okay, number 4. You're going to go to the calculate menu, number 2, and it's called 0. It'll ask you 3 questions, kind of like the vertex asked you those questions. These questions are left bound, right bound, and guess. Left bound, you actually have to move it for these questions, and guess. And then you write down your solution. That's the same thing as the x-intercept. That's the same thing as 0. It's x equals whatever that answer is. Alright, so we're going to use the graphing calculator for this. Letter A, 3x squared plus 7x equals 6. It's a quadratic equation, and it must be set equal to 0 on one side. So I just usually move everything to the left. You know, that's usually where the x squared is. So you'll minus this 6 over to both sides. 3x squared plus 7x minus 6 equals 0. And you put this into y1, and we'll just try zoom 6 on this one and see if that works. Alright, from previous, I'm going to turn the plots off, highlight that, press enter to turn it off, and clear out the problem that we did from previous. 3x squared plus 7x minus 6. I'm going to press zoom 6. And as long as I see where it crosses the axis there, that's going to be my two answers. Usually there's two answers. Okay, you saw the pictures on the front of the notes. So the way you get that answer is you go to the calculate, second calculate, go to the 0. And you got to get your little cursor, move it with your arrow keys to the left of the x-axis, the x-intercept. Get to the right of it, press enter, and then get on it and guess and press enter. And this answer is -3. X equals -3. All right, and the other one, calculate, 0, left bound, get to the left of the other intercept. There's good, press enter. Get to the right of it, press enter, and get on it and press enter. And 0.666666, we get a decimal on this one. X equals 0. All these sixes. Okay, remember you have your math fraction button, because sometimes my math lab is picky about how it wants the answer as a fraction. So I'm going to the little quit thing here, going back to my home screen, second quit, and I type in the 0. All the sixes, math, and press enter for fraction, and that's 2/3. So that's the two spots on the problem where it crosses the x-axis. So those two things are called the solution. We solved it. They are called the x-intercepts, and they are called the zeros of that quadratic. Okay. Next problem. Press y equals. The next problem is already solved for 0. So 3x squared minus x minus 10. I'm going to press zoom 6. Has to be solved for 0, so I did zoom 6. And we're going to calculate number 2, the zeros. That's where it crosses the x-axis, and I can see them here, so this is a good picture. Calculate the 0. Left bound, right bound, and guess. Whoa, too far. Left bound, right bound, press enter each time you do those and guess. So it tells you that the 0 here is -1.66666. X equals -1.6. All these sixes. We'll convert that to a decimal. Let me go get the other one. Calculate. So yeah, there's ways to solve these by factoring. There's ways to solve these by quadratic formula, completing the square, all kinds of stuff. This answer is 2. So x equals 2. Remember, that's how you write that solution. And this one I need to convert. -1. All the sixes. Math and enter for fraction. -5/3. That's called the solution. That's called the x-intercept. That's called the zeros. All right, this one is not set equal to 0, so add 6 to the other side. -5x squared plus 2x plus 6 equals 0. These I will get decimals for. These will not turn into fractions like those will. When it's a repeating decimal like that, it'll turn into a fraction, or if it's a terminating decimal. But you'll see the decimals on these, so we'll just round these 2 places on these decimals. Let's give this one a try. So remember, look at the picture, it's concave down. When the A value is negative, that's your A, your B, and your C. When the A value is negative, it's concave down. And that's how this picture is. That's just a review question. So let me see, I want to calculate the 2 and do left bound. Press enter, right bound, press enter, and guess. Press enter. -0.913553. x equals negative 0.91. If you type that in, not that, but if you type that problem in 913553 into the calculator and do the math fraction right there, it won't turn it for you. It'll leave it as a decimal. So yeah, sometimes you do get the decimals. Convert them if my math lab asks you to, but just look, sometimes it wants you to round it 2 places. Calculator, 0, the other one. Get to the left of it, which would be here. Get to the right of it. You're just setting the boundaries by answering these questions. That's all you're doing for the calculator, setting the boundaries. 0 is x is 1.31. That's the other answer. Okay, another decimal on this one. 2x is already set equal to 0. Negative 2.83. Negative, no, not negative, I'm sorry. Positive 2.83. Okay, so around the 2 places on there. This next one, let's just graph it. It's already solved for 0, equal to 0. So type it in y1. I'm going to do, oh, I wasn't looking, sorry. Let me delete this other stuff. Okay, zoom 6. Ah, what did I do? That little thing there. Let me clear it out. I wasn't paying attention. Okay, this one I did zoom 6. Didn't see all of my picture. I know it's a parabola. I know that it opens up, so it's going to cross the x-axis 2 times. I see in the picture it's crossing it 1 time, so let's do a different zoom. Let's do zoom out. There we go. All right, calculate 2. Left bound, let's see, I'll leave it right there. Right bound, guess. 0.61. X equals 0.61. So we had to do zoom 3 on this one. And then the other x-intercept. Left bound, right bound, and guess. 11.36. Or 339. That's a 3.8 rounds to a 9. So x equals 11.39. All right, next one. Minus 18 on both sides on this one. And press zoom 6 and let's see what picture we got. And I can almost see that. You can, remember, let's do window right here. And let's just increase our X maximum just a little bit right there. Let's just go to 15 and hit graph. So I did a little window adjustment here. And you can see it better. All right, calculate. 0. X equals 1.76. And 10.24. Alright, so bonus question right here. This is written in vertex form. We had that on our other notes. And I'm asking, what is the vertex here? Okay, remember in your other notes, it has the H and the K. Okay, remember the H we take the opposite of, and the K stays the same. It's just a little question from earlier. So 6, and that is a minus 18. It stays the same. So this is the vertex of this problem at the point 6, negative 18. And you can look on that graph right there that it's a little bit further down, so it's way down at negative 18. I can make my adjustment and see it down there, but I'm just asking where the vertex is as a bonus. All right. Next question. Word problem, height of a ball. Let me see if it is fit. All right. Let's look at our formula. S represents the height of this ball in feet. T is the number of seconds after the ball is thrown. So we have our T and we have our S. So T is the number of seconds, and this is the height in feet. Okay. Height 64 feet per second. They plugged in everything for us at initial height of 80. So they plugged all that in for us like on our other notes. And sketch a graph and then answer the question. So we're going to sketch a graph. We're going to look at our table to get a good window for our graph. So I want you to write this down. X min, X max, Y min, and Y max. All right, go ahead and type it in Y1. All right, let's look at our table. All right, remember what the X represents. X represents seconds. You can't have negative time in seconds, okay? So 0 seconds, and then, so there's the 0. And 1 second, the ball is at 128 feet. 2 seconds, 3 seconds, 4 seconds, and then 5 seconds, something happens. And then 6 seconds, it's at negative. And our Y values here, that's our Y values, the S's. This is the X's, this is the Y's. So the Y values represent the height in feet. You can't have the negative feet. So can't have the negative time in seconds. So I'll go 0 up to a maximum of, I'm just looking at the thing. I'll go to 6 just so we can see all of it. The Y minimum, I'll go to the negative 112, even because it's right there on the problem, even though I know negative does not exist on this problem, negative feet down under the ground. And then the maximum for the height, it looked like 144, so I'll just go to like 200 for this. So I'm looking at my table to get a good picture of this. Press the window and change the numbers for this problem. And that stays a 1. Negative 1, 12, and 200. Press graph. And there's the ball being thrown. Okay. So sketch that right here. Sketch that graph. This is T, that's your x-axis. This is your S, that's the height. And remember we saw on our table that number 5 right there. Look at the thing there, 1, 2, 3, 4, 5. So mark that off, 4, 5. And then there was the 6. So it started at 80. Let's see, it goes through there like that. No, that ain't good at all. I didn't make a very good graph at all. Let's do better than that. There, that's better. Didn't have a good curve in it. All right, and that was 5. All right, so how high is the ball after 4 seconds? Look in your table for that at x equals 4. 80. 80 feet. What is the maximum height the ball will reach? I'm going to calculate the maximum here. And this is what we did in our other notes, left bound, right bound, and guess. I'm doing the vertex here. So I'm calculating the maximum, which is our vertex. Press enter for left bound. Press enter for right bound. And just somewhere in the middle what it looks like for the vertex of this parabola. And 144. I have this at 1.99999. So that is the x value of 2 and a y value of 144. So what is the maximum height? The y value represents the height. So the maximum height is 144 feet. We did see that in our table, but that value is not always in our table. After how many seconds is the ball at a maximum height? It was at that at 2 seconds. We found that from our vertex again. So that was a value from our vertex. 2 seconds. How long will the ball be in the air? Well, if you remember our table, it started at 0 in the air. Look at the arrow there and goes all the way down to here, and that was at 5. So 5 seconds. It was in the air. The next question, when will the ball hit the ground? And that was also at that 5 seconds, okay? So I want to show you how to calculate that value. Calculate number 2, the 0. When will the ball hit the ground? That's where it's crossing the x-axis right there. See this point right here? So I know it was in the table, but I want to remind you what we were doing here. Calculate the 0 of that. Calculate the 0. So get over there to that value. And do the left bound, the right bound, and the guess. Left bound. I might be too close on that. Right bound and guess. Let's see. 5. It gives us 5. 5 seconds. I keep doing that. All right. How long after the ball is thrown is the height 100 feet? Okay, so I'm showing you something right here. If this is our formula, S of t equals 80 plus 64t minus 16t squared. S represents the height of 100 feet, so 100 goes here. 80 plus 64t minus 16t squared. We already got this in y1. I'm going to put this in y2, and I'm going to calculate number 5, the intersection. Okay, I want you to watch it draw this, the intersection. Press y equals, put your 100 down in y2, press graph, and you'll see a straight line being drawn. That represents 100. There's 100. So right there at that point, the ball reaches 100 feet. And then again, when the ball's falling, it reaches at 100 feet. So I'm going to calculate number 5, the intersection. And I'm going to come over here and do the left one. You got to get close to it on this. Remember, when you do the intersection, you can press enter, 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 but you got to be close to the one you're doing. So right there, 0.34. So time in seconds is 0.34 seconds. And then the other one, calculate number 5, the intersection. You got to get close to it, or when you press first curve, second curve, and guess, you got to get close to it, or else it'll give you the same answer it just gave you. That's good. Enter, enter, enter. And it'll tell you that that intersection is 3.66. Time equals 3.66 seconds. So those are the two answers, that the ball reaches 100 feet. So that was something we've done already. So that was just a good review problem there. Next problem. All right, let me see if this is lined up. Yep. All right, graphical methods. They are used for word problems. Okay, the problem will say find the solution. The problem will say find the 0. The problem will say find the x-intercept. All that means the same. Okay, So now we have a profit function. And notice the A value, this is A, B, and C. Notice the A value is negative, so it's going to open upside down, kind of like that ball being thrown. So you have your profit increasing, and then it reaches a maximum profit, and then it decreases. So we're going to use a graph to find the levels at the daily sales. So I'm going to look at the daily sales equaling 1,400. So the letter P represents the daily profit. The daily profit equaling 1,400. 1,400 equals negative 0.01 x squared plus 20x minus 500. Right, 0.01 x squared plus 20x minus 500. And I need to do the y2 value to equal what? 1,400. Alright, we need a good window. So I'm going to go look at my table for my window. This is y1, this is y2. I'm looking at my table to get a good window. X min, X max, Y min, Y max. Alright, X represents units produced, and so I'm looking at the X values here. For 0 units produced, they have a loss of negative $500. Two units, sale and production of 2 units, 10, 11. So let's see, we got to keep going here. And what are we getting? Negative 116, 21. All right, so now we get some profits here, okay? So let me do my table settings. 0, count by 20s, just to get there a little quicker. Let's just look at this. 0, 20, 40, let's see. 11, 1,600, 2,000, let's see, keep going. All right, 39, 48, 53, 58, my profit, 68, 74, 85, 9, 10,000, 11, 12. All right, where was it around that 1,400? It was way back here. So let me look at my window. 0, let me see where to go back to where that 1,400 was. I don't need it all the way to there, 1,600. So right here, about 120. So I'm going to put 0 to 120 right here. And I'm going to put minimum of negative 500. Remember, that's where it started for the profit. And the maximum, I'm going to put, I need at least the 1,400, and I see the 1,600 there. So I'm going to put 2,000 right here. Window. So my table gives me clues for all of those. I'm going to put that in for window. And just see this. There's my parabola. Even though I don't see all my parabola, there's my 1,400. So I'm going to calculate number 5, that intersection. And I'm going to do enter, enter, enter. And it'll tell me that that right there is at 90.87. I didn't put my negative in. I knew that was wrong. Negative. Let me change that. Look at it again. Calculate number 5. Enter, enter, enter. 100 is what that one should have been. At X equals 100 units produced. The profit is 1,400. So I did that in Y1, Y2, and I calculated number 5, the intersect. Next question, is it possible for the profit to be greater than 1,400? Yes, we saw that already. Okay, I'm going to add a question right here, question C, and I'm going to change this one to question D. Question C, what is the maximum profit? What was that maximum profit? I'm going to go back and look at my table. And it just keeps growing. Remember, I kept scrolling on there. So look here. For this maximum profit, remember this opens upside down. And I want to find the vertex. So I'm going to do a little review problem right here, finding the vertex of this problem. So I have my letter A equals negative 0.01. My letter B equals 20. So the vertex is x equals negative b over 2a, negative of 20 over 2 times negative 0.1. That's negative 20 over, let me do that, go back to my, right here, negative 0.01, I didn't put my 0 on there, did I, times by 2, and negative, what, 20 divided by that, and I get 1,000, negative 0.02, and that's 0.01, and I get 1,000. So that's the x value of the vertex. So x represents the unit. So at 1,000 units, it reaches the maximum profit. So I can go in my table now and find that 1,000. Table to 1,000. And that will be my max. So let's see. Let's go to table settings. And here's a trick. If you go to calculate, let me just show you something. If you go to calculate value, I hadn't showed you this yet, and tell the x value you want it to be 1,000. Let's see, it might do it. I might have to change my window for it. Yep, I got to change my window, so never mind on that. Let's go to the table. Table settings. Let's just start at 1,000. And it'll tell us our table. Right there, 9,500. So in the table, at x is 1,000, you get the 9,500 beside of it, and that's the profit. And that would be the max profit. We just calculated the vertex of this problem. So $9,500 is the max profit. How many units give the break-even point? That means when it equals 0. So if we have our vertex at 1,000 and 9,500, that's our vertex. It opens upside down like this. We need a window. X min, X max, Y min, Y max. Alright. X min, X max, that's the number of products produced. 1,000. Remember my tip on that other thing was to double that, so I'm going to put 2,000 on here. That was my tip on my other notes. And Y represents profit, 0, and my max profit was 9,500. I'll just go to 10,000 on that. And that should show us a complete graph. I might go a little bit more than 2,000. I might go to, no, that'll be fine. That'll be fine. Window, let's do 0, 2,000, 0, 10,000. Now there's our profit. And so down here, I can take that other one out. That other one was where the profit was 1,400. I can clear that one out. I don't need it. So down here is the break-even point, where it hits the x-axis, the x-intercept, the 0, the solution. Break-even means where it hits that 0, okay, on the x-axis. So over here I got to calculate. Let me see if it will do it for me. I might need to change my window just a tad. Let me see if I can do left bound, right bound, and guess. Calculate number 2, the 0. Ooh, too far. Left bound, right bound, and guess. So at 0, 1974.68. X equals 1974.68 units produced. You have your break-even point. You have your break-even point. 0 profit. All right. A little reminder here for your MyMathLab assignment, MyMathLab 3.2. Go back and review chapter 1.3 where we did our little profit equals revenue minus cost function. Profit of X equals revenue of X minus cost of X. There's one little MyMathLab problem about that.